Okay. So we have graphing derivatives and antiderivatives. Okay, so we're using the graphs to draw its derivative. So if I have an original function and I'm going to draw the derivative, what am I technically analyzing? The slope. So all I'm doing is I'm just kind of plotting the slope at specific points. Okay. So if I start with my original function, is everybody kind of with me right here? Yeah. Okay, so we have this wave, we'll call it. Looks kind of like a wave. Okay, and the very first point, it looks like it starts at the x value of negative 3.5. Okay, so if you were going to estimate the slope, okay, right about that time. Ooh, I don't know what's happening. Don't go away. Okay, so this slope right here, what would you kind of guess that the slope right at that point is? Hi. How you feeling today?
I'm feeling a little sore.
Me too.
My shoulder and lower back.
Yeah, me too.
Parlez-vous français?
No. I know enough to say no. Do you need me to talk out there?
We are still looking for coverage for third period French.
French. Oh, okay. I can sit in if I can push play. Is there like a...
Actually, they're working on packets. The students have already worked on these kind of packets, so
okay.
They'll keep themselves busy. You can bring stuff there.
Okay. Perfect. Okay. Sounds good. Yep. Okay.
So this is AP Calc?
AP Calc, yep. Mm-hmm. Okay, so slope right here was a positive 1, right?
Right.
Positive 2. All right. I'll go with positive 2. That's fine with me. Okay, so how about like right here? Like this is a really important one. When the x value is negative 2, what would you call that slope? Okay, 0. So max and mins, those are going to be really important ones. So negative 2, we're going to plot the point 0. Okay, and maybe we can even jump over at the x value of 2 because that's also, what's the slope right there? At 2 when the x value is 2? 0. Okay, what about like right about when it crosses the x-axis, what would you say that slope is? Like a negative 1-ish? I would agree with that. Yeah, right when it crosses when the x value is 0. Okay, so we could even go in like more specifically and like try to analyze what the slope is at negative 1 and kind of say, okay, at negative 1, what would you say that slope is? Negative, I don't know, maybe negative 1/2 maybe-ish? Whoa. What just happened? Sorry, I just, well, there. Okay, but we know that this has some curvature to it. Okay, so it's going to, if I connect these dots kind of, we can say that the first derivative looks like what? A parabola. Okay, now does it make sense to you that that would be the case?
Honestly.
Okay, because like if I was going to graph this original one or maybe come up with the equation for this original one, what might it be? Like the leading term. Close, x, the first one, x cubed. What's the derivative of x cubed? Wow. That doesn't even make sense.
3x squared.
3x squared. So the derivative would be an x squared. So it would turn into a parabolic function. So obviously there'd be some shifting, some slope change that we didn't analyze, but basically the shape we're looking for. Okay. Okay. So now going the other way. Okay, we call that the antiderivative. So if I'm given the graph of my derivative, and now I'm going to draw the original, Okay, so these are little things that we should look at. So make a first derivative number line by using the location or the position of the points on the graph. This does not involve the slopes. Okay. Then number 2 says make a second derivative number line test by using the slope. Because what does the second derivative test tell you? Concavity. So we can use that to tell us about the concavity of our original function. Okay, then we can combine the number line graphs and then try to figure out what it looks like. Okay, so kind of like what we did with the warm-up today, we're going to use the number lines to come up with the graph. Okay. All right, so I'm going to ignore what I'm going to draw initially. So the first piece of this is my first derivative, right? Derivative 1. So this has already been analyzing the slope. You guys with me? Okay, so this is the slopes of my original. Okay, so the most important slopes that I want to talk about is when the slopes are 0, because those are when we find critical values. So when do we have slopes of 0 for this?
3.34, 0, and 3.34.
Okay. Sure. I can't disagree with you. But I don't know if I'm going to agree with you. I'm just going to call that negative 3.5, 0, and... Okay. Okay, so when it crosses the x-axis, I know that those are going to be potential maxes or mins. Okay, so now notice that this only exists between negative 3.5 and positive 3.5, so I don't need to do test the intervals on the other side of those. We're just looking at in between. Okay, so if I look at between negative 3.5 and 0, is the slope positive or is it negative?
Positive, negative.
Okay, how do we decide that?
I can't.
Okay, so for me to decide if it's positive or negative, remember that this is showing me the slopes of it, right? So anything that exists above the x-axis is positive. So does the function exist above the x-axis or below between 0 and 1, 3, or negative 3.5 and 0? Okay, so it's above. So these are going to be positive slopes.
Okay, so the other one's negative.
And the other one is negative, right? So if you can remember that, maybe write that down somewhere and say, hey, we're looking at above is positive slope, below was negative slope. Okay, give yourself words that make sense to you. I know I do abbreviate a lot, but give yourself hints that will be helpful later. I'm looking at, does it exist above or below? Okay, so now I'm going to do a second derivative test right now. Hustle. Okay, so now I'm going to analyze the slope of this, which is going to help me with the concavity of my original. Okay, so I'm analyzing the slope for my second. So I'm looking for my max and min for my critical values. When do I have a slope of 0 on this given function? Good. So at negative 2 and positive 2, we have slopes of 0. So remember, we still only go to negative 3.5 and positive 3.5. Okay, so if I'm looking at the slope to the left of negative 2, do I have a positive or a negative slope? A positive. Okay, now if you look between negative 2 and positive 2, what kind of slope do you see? A negative slope. Okay, and what about when 2 to the right of 2? Positive. Okay, so now what I just did is I now can analyze the concavity of my original function. Okay, so I'm going to start with a happy face, then a sad face, then a happy face. Okay, so now I'm going to ignore that first graph and I'm going to take these number lines to help me draw this. Okay, so I do know that this function goes up and then goes down, and it did tell me that I have a starting point at the value 0, 1. Tell me about the point 0, 1 other than it is starting. What else is it? It's a max, and I know that based on my first derivative. Okay, so the point 0, 1 right here is a max. Okay, so I know this function goes up, goes down.
So,
Okay.
Miss Melty, so is that point from 0 1 going to go down or negative 2, negative?
Well, there's going to be some more information. Now, the rest of this is going to be kind of like just roughly drawing it. Because I don't have any other points and I don't have a function to plug it into, I do know that there is a point of inflection at the x value of -2 and at +2. Okay, so if I kind of go off of my graph to the left of the max, okay, I know I have a positive slope, but what kind of concavity? Negative. So I have this sad face that goes down until we get to the x value of 2. And I don't know where this y value is, so I can just draw it somewhere. Why? What do you mean, what negative? Oh, sad, the negative concavity? Right here, right? When we're looking between 0 and 2? Okay, so between 0 and 2 we have like this sad face, so it's going to go down. Wow, that was a really bad curve. Okay, so we're just going to pretend that maybe it goes to the point -2, -1. I really have no idea what the y value is, but I'm just going to throw it there so that we have something to look at. Okay, so now remember, my function only goes to -3.5. So between -2 and -3.5, what kind of slope do I have?
Again?
Oh,
A positive slope with what kind of concavity? Positive. So if I have a positive slope with positive concavity, which little curve am I going to draw? That one, right? So I'm going to draw that cup coming up this way. Okay, so it kind of looks like that. I'm going to stop drawing when I get to about right here. Okay, so now let's just say this is like symmetrical because that'll help us kind of draw it. So now if I go to the right side of 0, okay, I'm going to draw what kind of slope? Negative. And when I get to +2, what kind of concavity between 0 and 2? Negative. So I have a negative concavity, negative slope. Which one am I drawing? This one, right? So I have to draw that down, and I'm going to just kind of pick a y value that kind of looks nice. I'm just going to throw it right there. Okay, and then my last little piece here, again, has a negative slope, but now a positive concavity. So we have a happy face. Which one is my negative slope? This one, right? So it's going to kind of curve out. And again, we're going to kind of stop when we get to 3.5. So I don't really know what y value, so that might be vertically compressed, or it could be vertically stretched by a lot, but it should generally still have that shape. How did we do on that? Did that kind of make sense? Okay, so it does help to draw those number lines. Like, I think those are really vital in doing that. Is that it? Oh. Okay. So question number 3 says use the first derivative to sketch the second derivative and the possible original. Okay. So this is kind of putting both of these things together. Okay, so I'm going to start by going to the second derivative. Okay, so if I'm starting at a first derivative and going to now draw the second derivative, what am I drawing? The slope of it. Okay, so if I go from first derivative to second, I'm just going to draw the slopes of this graph. Okay, so this is a straight line from -infinity to 2. What is the slope of this line? 1. Okay, so I'm going to draw the slope of 1 from -infinity to 0. Yes?
Oh, I was just so couple 1.
Oh,
That was a slope.
perfect. Okay. All right. So now the second side, or the right-hand side, has this curved. So it kind of starts flat, right? Would you kind of consider that this maybe was like a 0 when I got really close to this. And then the higher I go, the slope is... The higher I go, the slope is... Higher. Higher. Yeah, so like the further away I get from this, the x value of 0, it gets higher and higher. Okay, also I can think of like, what would be a maybe equation for this little side?
X squared.
X squared, right? So, I don't know.
Somebody's
Dancing. Okay, if you were going to derive x squared, what is the derivative of x squared? X. So what is this line over here going to look like? It's going to be a straight line. Okay, and it's going to start close to 0, right? Because this would be potentially like close to 0 right there because it would have been a minimum, and then it would get higher. So I don't know exactly how steep it, wow. It could be, but it's probably about that steep. Right, so exactly. So that's what I was saying like about the steepness. So without me really knowing like the original equation, I can't really say how steep that my red line is. It could be with a slope of 2, you're right. But for me to like not overanalyze it, I just know that it's straight. So if you want to draw it steeper, I can't disagree with you. Sure. Okay. For the slopes?
Yeah. Dude, this slap of the ball.
Does it make sense on the linear one?
Yeah, well, I know why this. I know the slope is 1, but why is it like
the curved one? Okay, I'll help you with that. You just gotta kind of, I don't know, it takes practice. I'll help you with it. Well, because the slope, like, so like if you're gonna start right here at 2, it would potentially be at like 0, right? So I start just to the right side of that, it's really close to 0. And then the further away I get, it gets higher and higher and steeper and steeper. And it's a positive slope.
You're right.
Okay, so let's do the first derivative number line test. Can you tell me what kind of critical numbers that we have? What am I looking for? Okay, I'm looking for where it crosses the x-axis, and it crosses the x-axis at -2. Okay, when you're to the left of -2, does it have a positive or a negative slope?
Negative.
Negative because it exists below.
The x-axis.
Exactly, and then when we get to the values greater than 2, positive. Okay, when we look at the second derivative, okay, we're looking at the concavity. Can you tell me where the critical number exists? Okay, could be, yeah, kind of 0. 0 might be critical because there's a discontinuity maybe in there. What kind of concavity does your...
Left side has nothing.
Yeah, so, what?
Basically.
Basically? But the other side
So, what? So remember that we're analyzing the slope, right? So is the slope positive or negative? Positive. So we're analyzing slope of the first derivative. So it's positive on both of them. Positive, positive. Yeah. Okay. So I know that this function goes down and then it goes up. Okay, so what is happening at the x value of -2? Min. Okay, so, and then we have this positive, positive, so it doesn't really matter where we choose our y value to be. So let's just say our point is going to be at -2, I don't know, -2. Okay, so to the left of -2, I have a happy face with a negative, or excuse me, yes, a negative slope. So which one has a negative slope? This one, right? Okay, so happy happy face. It's a new word. Okay, so happy face, negative slope looks something like that. Okay, now to the right of it, we have a happy face with a positive slope, and probably what happens when we get to 0 is that curvature just gets a little steeper. Okay, so it's like, instead of like a kind of a flat bowl, it's more of like a steep bowl. Okay, but it's still, yeah, like a vase. Okay, so we're going to have a happy face, positive slope, so it's going to kind of go kind of a nice curve, and then when we get to 0, then it's going to be like super more curvy. It's not a great drawing, but it would be a steeper curve.
Do you know on where on the y-axis?
No, so I can take this function and vertically compress it or vertically stretch it. I have no idea where the y values exist exactly. Okay, you good? All right, so